fall. The right one must be left. Straight ahead is never good at all.
Hello and welcome back to the problems video. This is for integration in two variables. Okay, so the first problem I'm going to start with, I'm actually going to show you how to solve it in two ways. But I mean, there's one like standard way to solve it, but I just want to show you, for explanatory purposes, the second way. Okay, so this is our problem. We're given the double integral of this, and as you can see, the f of x, y equals 1, so that's good. Ones are always good. Ones and zeros, that's what I've learned from my math career so far. Ones and zeros are pretty good. Okay, so basically, we're going to split this up using our parentheses, right? So we're going to do the inner integral first, and then the outer one. So for the inner one, from 9 to 4, okay, that's just going to be x, and this is from x equals negative 3 to x equals 8, and then dy just stays out there. So this becomes from 4 to 9, and then we have an 8 minus a negative 3, right, and then dy is there. Then we get 4 to 9, and this turns into 11 dy. So this is 11y, from y equals 4 to y equals 9. So this is 11 times 9 minus 11 times 4, which is 99 minus 44, which is 55. So this is our answer. So that's good, and this is the way you'll do most problems, is you just get the answer. But in this case, because we had this special condition up here, remember what I said in the beginning is that when you have something like this, then the double integral over d, like this, is going to equal the area of d. Okay, so the area of your domain. So let's just see if that's true. So here's the second way to do it. Just this problem, actually. So here's our problem again. Negative 3 to 8, and then 1 dA, okay, or dx dy, either way. So what I'm going to do is draw, whoa, that was a weird line, draw out what our domain looks like. So x goes from, x corresponds to these ones, and y corresponds to these. So x goes from negative, wait. Okay, yeah. So from negative 3, 1, to, okay, hold on. I'm going to do some scalar things here. I'm going to count by 4s, so it just makes it easier. 1, 2, 3, 4. Okay, so this is negative 4, this is positive 4, positive 8, positive 12, positive 4, positive 8, positive 12. Okay, so if x is going from negative 3, so negative 3 to 8, so these are the lines here, those are the bounds on x, and then for y, it's from 4 to 9, which is about here. Alright, so this is from 4 to 9. So basically, 4 to 9, and this is from negative 3 to 8. So this is our domain here in the rectangle, right? So that's our domain D. So let's find the area of it. So our this is our length and this is our width, we could say. So area of a rectangle is length times width. So our length is going to be 8 minus negative 3. So that would be 8 minus negative 3 is 11. And our width is 9 minus 4. So that would be 5. And so in this case, we proved that equation up here. We proved this true. So anyways, that was just the second way. I just wanted to show that and give some more insight. Alright, now on to the next problem. Okay, so here's the next one. We have integral from 0 to 4 and integral from 0 to 5 of dy dx over square root of x plus y. Okay, so let's rewrite this as separate ones. So then our inner one is going to be 0 to 5. Dy comes first. So this will be 1 over x plus y, and I'll write the dy here, and dx is there. Okay, so these two are the same thing. It just makes it a little bit more visually understandable. So I like to rewrite anything on the bottom, like of a fraction, as a negative exponent. So I'll just rewrite this as that, negative 1/2 dy, and then our dx is just on the outside there. Okay, so let's just integrate, and we're going to do so holding x constant. So x is a constant, so treat that like a 2 or a 4 or anything like that. So it's just going to be moving around with everything. So 0 to 4 on the outside, and then we have, when we integrate x plus y to the 1/2, to the positive 1/2, so that means in front we have to have a 2, and this is when y equals 0 to y equals 5, and then dx. Okay. So now what I'll do with this constant is just bring it all the way out in front, so we don't have to deal with it until the end. That's what I like to do. So I'll put the 2 out there. It's not going to make a difference really. And then on the inside, what we have is, so this is a 1/2, so that just means square root. So if we're going to plug in 5, so we have x plus 5, and then minus an x plus 0, so that would be square root of x, and then we have dx. Okay, so now we're down to single variable calculus again. All right, so now we just solve from here. So I'll turn it into exponents first, because I like to do that. X plus 5 to the 1/2 minus x to the 1/2, and then everything dx. Okay, so now we can integrate, and we get x plus 5 to the 3 over 2. So that means you have to have a 2 over 3 in front, minus an x to the 3 over 2, and you have to have a 2 over 3 in front to balance that out. Okay? And then x is going from 0 to 4. Okay, so now we just solve. So we have 2 just stays out in front for now. And we have 2 over 3 times 4 plus 5 to the 3 over 2 minus 2 over 3 times 4 to the 3 over 2 minus, and then we're going to have, when we plug in zeros for everything, 0 plus 5 to the 3 over 2 minus 2 over 3 times 0 to the 3 over 2. Okay, so now we're just going to simplify. And what we get is 2 times 2 over 3 times 9 to the 3 over 2 minus 2 over 3. Okay, so 4 to the 3 over 2. 4 square rooted is 2. To the third is then 8. Okay, and then we have a minus 2 over 3, 5 to the 3 over 2, and this is just 0. Okay. So then we get, I'm trying to squish it in at the end here, 9 to the 3 over 2. So first you square root it, and you get 3, and then 3 to the third is 27. So 27 times 2 is 54, and I'm just doing it out loud so that I can save some space here. So that's 54, sorry, that's a 5. 54 over 3 minus 16 over 3, and then minus a, I'm just going to leave that as it is because that's not really easily simplifiable. Okay, so that's what we get. And our final answer is, I guess the simplest way you could write it is 76 over 3 minus 4 times 5 to the 3 over 2 over 3. That's the simplest way you can write it without a calculator. So, oh, I drew the line through the answer. Okay, wait for it. Okay. Okay, so that's the answer for that problem. And now on to the last problem.
But no one answered me, no one